This is Math 2, Section 3.2, Day 1. First thing that I would like you to do is to pause the video and go in and read through this section. Read through this section, get an idea of where we're going, everything. So again, please pause the video and go read it. Seriously, pause the video and read it, because I'm not going to read this to you as I go through, and then you're not going to know what's going on as we're going through because you won't have read it. So please pause the video and go read the section. Thank you for doing that. I appreciate it. All right, we're going to jump right down here to number 1. Given the facts listed above, which you read, how can the twins figure out how much of the account will be worth in 5 years and when they are 20 years old? Describe your strategy and calculate the account balance. Hopefully it makes sense to you that what we could do is, since they're starting with $382.88, right there, $382.88 in the account, and how much are they going to have in 5 years if they're getting 5% interest. 5% interest. Well, we could take that 382.88 and multiply it by that 5%, and there's not that much space over here. So let's go next door to page N7. This is page N7. And up on the top, for after the first year, we're going to take that $382.88 and we're going to multiply it by that 5%. There's the interest, and you can do this on your calculator and you will get 19.144, which is, I'm sorry, can you see the shadow? This because the table I'm on has a light up here and it's shadowing. I'm so sorry about that, but there's nothing I can do. So that's the amount of interest that they make. So how much money is going to be in the account is going to be the original amount, $382.88 plus $19.14, which is $402.02. That's after 1 year. After a second year, we'd have to take that $402.02, multiply it by 5%, and when you do that, I don't have that one off the top of my head right away, 402.02 times 0.05, that gives us $20.10. It does give us that third decimal place, but because we're talking money here, we do want to round that off to be just 2 decimal places. So how much money is in the account now? That $402 plus this $20.01 or 10 cents interest. And now they have a total of $422.12. After a third year, same thing. We're going to take this $422.12, multiply it by 0.05, get whatever we get, and then take that answer, whatever it is, and add it to the original amount, that 422.12 plus that amount right there. And that gives you kind of a procedure to go through. Now, this gentleman, Carlos, so we're going to go back to page 7. Okay, so we just did this. See page N7. And Carlos just did that. And he got all of these numbers over here. He left this fifth one blank over here. Can you guys go figure out that fifth one right now by that same procedure? Please pause the video and work through that one on your own. Seriously, pause the video and work through it on your own. Welcome back. I hope you got 488.66. $488.66. If you missed that, or if you refused to shut off the video like I asked, then here it is. 465.39 times that 5% interest gives us $23.27. And then we're going to add 465.39 plus 23.27, and we get 488.66. All right, now Clarita thinks that this is a pain in the neck to do this. She thinks there's an easier way to do this, and there is, if we realize that we're multiplying by the same amount each time. Be very careful here, because some of you are going to want to think that you're multiplying by 0.05 every time, but you're not. Go use your calculator right now and see if you can figure out what we're multiplying by each time to get from one term to the next. Seriously, do it. On your calculator, divide out a pair of these. I don't care which one. Bottom divided by the one up above it. You should get that we're multiplying by 1.05. So when Clarita can write this equation, she can get that y equals, it's exponential. We're multiplying by 1.05 every time. So initial amount, they started with $382.88, and they multiplied by, every time, 1.05 to the x. There we go. There's Clarita's question, or idea, actually. All right, look at this next one. So we'll flip the page. We are going up to page 8, where Carlos was surprised that Clarita's formula gave the same account balance as the year by year. Explain why this is so. Here's what we actually did with Carlos's first method. We took the 0.05 times the 382.88, and then we added that to 382.88. Now, without multiplying this out, if you remember some of the things we did from last chapter, we can factor out what's common. Factor out that 382.88, and that's going to give us 0.05 plus 1, which is 382.88 times 1.05. That's where the 1.05 is from that this Carlos couldn't see. All right, now, as I said, you've read this before, so I'm going kind of fast through the reading. If you did not pause this earlier, please do so and read through these so that you can catch up with me. Or if you need to pause this and read it alone or again a second time, then please do so. Okay, this time Carlos wants to go backwards and fill this in. Let's go back and fill this bottom one in. We already figured that one out. That was 488.66. Going backwards, well, we know to go forward, we had to multiply by 1.05. So to go backwards, we're going to have to divide by 1.05. Multiplying by 1.05 goes forward. divide by 1.05 to go backwards. Please do that. Pause the video. Seriously, button push this on your calculator. Welcome back. Check the numbers. It's a 347.29, 330.75, $315 even, and $300 even. That's Carlos just working between the individual years. Clarita wants to use her formula for -5 and see if we get the same thing. So Clarita's formula was that exponential formula. I'm going to jot it down here again. It was 382.88 times 1.05 to the x. And we want to figure this out at time -5. So that's 382.88 times 1.05 to the -5. I think my computer's dying. Hold on, let me plug it in. Okay. That would just be terrible if my computer died in the middle of all this, wouldn't it? Absolutely. Alright, so let's go to a calculator and we're going to type this in, and to get that -5 exponent, 382.88 times, you don't have to put a time sign there, a multiplication symbol, you can go straight to the parentheses, 1.05, close parentheses, and then use this caret up arrow to the -5, and 299.996, which rounds to be exactly 300, absolutely. All right, now explain why this works. How come this gave us, with the negative exponents, gave us the same thing? And it all goes back to just a couple of days ago when we talked about negative exponents. A negative exponent moves the base to the denominator. So this is 382.88 times 1 over 1.05 to the 5th. And there's your 382.88 divided by 1.05 5 times. So you're taking that 382.88 and dividing by 1.05 5 times. All right, moving on. Let's look to page 9. Again, if you did not read this far, please pause the video and go read and kind of get a idea of what's going on here. We have to calculate the account balance in 2 different ways if they withdraw their money a half a year from now. We're going to come right down here and kind of talk about what Carlos did and about what Clarita did. So Carlos, he calculated how much interest they should be paid for in the full year, took half of that, and then added that amount to the current account balance. So how much did he make in 1 year? Was 382.88 times that interest rate, 0.05, and that was the $19.14. Half of that is $9.57. So that's the interest that they made. So the money in the account that account is this 382.88 plus that $9.57 is 392.45. Clarita said she's going to substitute half for that n. So Clarita said she is going to do 382.88 times 1.05 to the half. And you can do that on your calculator the same way. Actually, I'm going to show you something. If you have a newer calculator, you can arrow back up. I'm just hitting the up arrow and I'm arrowing back through my lines of text, and I get to here. I'm going to change that exponent from a -5 to a 1/2. And then I'll have to retype the whole thing. This time we end up with $392.34 in the account. Okay? If you subtract that off, what this one made was only $9.45 in interest. Okay, this time Carlos and Clarita did not get the same result. Who do you agree with? That's an opinion question. I'm going to tell you though that Clarita is correct. Because she's following an exponential function. Carlos is following a linear function. Pause and read this next part. You need to understand that before we get to number 9. Because thank you for pausing and reading that. And here's why, because it says carry out the computations that Clarita suggested. So let's do these computations that Clarita suggested. She says if your method works, we should be able to take half of that amount. So half of the 82.51 they said, which is $41.26. Add that onto the account balance, so $41.26 plus the $382.88, and that should equal year 2 in the table. When I add these guys together, though, we get $424.14, which is not the same as year 2 in the table. So Clarita is proving that Carlos's method is incorrect. Turning the page here, page 10. The points from Carlos' table, came from question 2, have been plotted on the graph at the end of this task along with Clarita's function. Okay, so we're going to take a look at that graph. Here's this graph, and it's on page 11. And what I want you to see here on page 11 is that Carlos' first strategy, which he was actually doing exponential, that was actually when he was doing the 5% times the number and then adding it to the original and then finding the next year. That's the solid line. That one was exponential. Carlos's second strategy which is linear, or these the dotted lines here. All right, flipping back to page 10. 10, so I just flip the page back. And it's telling you to plot the value that you calculated in question 9 on this same graph. So let's go back to question 9. Here's my question 9. 10. Where's my question 9? I put it away now. Oh, here it is. Found it. Phew. Question 9 is 424.14. So we're going to put that on the graph. $424. Oh, it's right there. It's on the linear one, which we know was the wrong one. That was the wrong one. So this point was on the dotted line, so this method was for a linear function. The value you calculated in question 9 is on the dotted line. So this method was for a linear function. Okay, now plot Clarita's and Carlos's value for the half year, which was question 8. Question 8 was for the half year. And at the half year, oops, I did that last one wrong, number 9. I was thinking I was on the half year. That's wrong. Oh my goodness, I'm sorry. At the 2-year point was 424, which was right there. There's for question number 9. Number 10, then it said look at number 9. For number 11 says for the half year, which was question 8. So the half year we have to go back to, I'm so sorry, I hate all this flipping pages, it drives me bananas. Right here, it's this one actually. So Carlos had a 392.45 and Clarita had a 392.34. 392.45, so half year, 390, right there. That was one of them, and there was the other one down here. Here was Carlos, and this is Clarita. Oops, couldn't see it, sorry. Sorry. And I'm just going to jot these down in here so you have them. So Carlos was 392.45 and Clarita was 392.33. And I put those on here for us, and we see that we're close, but not the same thing. Okay, now let's go on up to page 12. And I know I went through fast. Again, if you need to go back and pause it and listen to it again, please do so. Your assignment, let's go to page 12. So this is section 3.2, day 1. You are going to do pages 13 and 14. Questions 10 through 24. 13 and 14, 10 through 24. I do want to show you something very quickly. Over here on page 13, We're talking about arithmetic means and geometric means. Arithmetic, we're just figuring out what are you adding to get from one term to the next. And we've done that a bunch of times now. That's for the arithmetic means. Figure out what you're adding so you could find that number. Geometric, figure out what you're multiplying by. And we've done that a bunch of times now. So figure out what you multiply by so that you can fill in those boxes. Same idea happens down here on the bottom. With this big one, you want to go from 4 to 16, and then from 16 to whatever that is. And then you also want to look at the other ones in there. So you can figure out what you're multiplying by if you were going just these long ways or if you were going these little bitty ones. Same concept throughout. Thank you very much. Have a very nice weekend.